Hello, Arsha. Can you hear me?
Yes, ma'am.
Okay. Just a minute. Martin is also trying to join. Okay, Arsha. So which question we were doing in the last class?
I didn't join the last class. I was up. I wasn't there.
Why were you absent?
I was out.
Okay, but do one thing. Now take the recording from the office, okay?
Okay, ma'am.
So whichever classes you have missed, you can you can always ask for the recordings. But
In the Learnivio website or personally in WhatsApp?
I think you have the WhatsApp number or the
Yes,
Learnivio
yeah,
office
yeah, I
number.
do.
Yeah, so you can just contact on that number.
Okay, ma'am.
Just send them the date which you missed and topic, so they'll send you the recording date wise, or the complete chapter also can be shared. Yes, Martin, can you hear me? Okay. So Martin, we were doing question number 4, right?
Yeah.
Okay. Okay, Arshia, anyway, we discussed the two theorems of circles, right? Just a quick recap. So there are only two important theorems here, just pay attention, right? So the first one is like if you have a circle, right, with center O, and then this is the radius, right? So at the end of the radius, if a tangent is drawn, so this tangent and the radius are perpendicular to each other. This is the first theorem. Understand? Yeah, please say yes or no. Please unmute yourself,
Yeah, ma'am.
both of you.
Yes, ma'am.
Okay. Yes, Arshia, you also please unmute yourself.
Okay, ma'am.
Okay, so this is the first theorem, right? Now this can happen at any point of the circle. The radius can be here, right? So this is a tangent here, or you can take a radius, this radius, then the tangent is here. So at any point on the circle, whenever a tangent is drawn and at the point of contact, so this point is called the point of contact, right? So at the point of contact, the radius and the tangent are perpendicular to each other. This is theorem number 1, right? So this is we are using. Now second thing, if you have a circle and then you take any external point, right? Any point outside. Now from this point, only two tangents can be drawn on the circle. This will be like, sorry, one tangent, right? And this will be the second tangent. Understand? So first thing is only two tangents can be drawn from an external point. Okay, is my screen blinking or is it fine with you?
Now it's okay.
Okay. So this is the center O, right? Now this is the point of contact and this is the second point of contact. Understand? Sorry, 1 minute. Right? So from this point P and these two are the point of contact. So this distance PA will be equal to PB, right? That means the length of the tangent from an external point are equal. Is that okay? This is actually your theorem number 2. So that's it. These are the two important things we are using here. So I think I was on question number 4. Yeah. No, Martin, was I on question number 4? Yeah, I think in your batch I was on 4th. Just please check. Yeah, please check.
I'm around 6. I'm gonna do 6.
6th, okay. Okay, this is the sixth question. The length of a tangent from a point at distance 5 centimeter from the center of a circle is 4. Like you have a circle, right? This is the center O. The length of the tangent from a point A. So there's any point A. Let's say this is the point A. At a distance 5 centimeter from the center. So from the center, this point is at a distance of 5 centimeter. Is that clear? Okay. So the length of the tangent is 4 centimeters. So length of the tangent will be from, let's say this is the tangent which is drawn from this point, right? So this is the point of contact. So this length is 4 centimeter. Now find the radius of the circle. So this radius you have to find. Let me call it P. Clear? Okay. So yeah, Arshia, is there anything I can do here? How will I find the length of OP? Can you guess something?
Ma'am, Pythagoras theorem.
Okay. Arshia, can I use Pythagoras theorem here?
Yes, ma'am.
No, I can't. Now please see here carefully. Pythagoras theorem can only be used if it is a right angled triangle. Understand?
Ma'am, but then it's right
Radius.
angle, right?
Yeah,
The
so
angle of P.
so first we have to show that it is right angle triangle. That's what I'm saying, right?
Then that
So
property has radius
yes,
perpendicular.
yes, so you will first of all mention the theorem, then you will say that this angle is 90 degree and therefore it is a right angle triangle and therefore we can use Pythagoras theorem, right? I mean, you are right, but do stepwise. So since AP is a tangent, so write like this. Since AP is a tangent, so therefore OP is perpendicular on AP, right? And therefore the angle OPA is equal to 90 degree. Is that okay? So triangle OPA is a right angled triangle. So now you can use Pythagoras theorem. So using Pythagoras theorem, so Pythagoras theorem, so this will be the hypotenuse, right? So OP square will be equal to, oh, I'm sorry, OA square. Just 1 minute. I think I should use my whiteboard. There's some problem here. Yeah, so this is the triangle I'm having. Is it better now?
Yes, ma'am.
Yes, ma'am.
Okay, so this is a right angle triangle. So here OP square plus PA square will be equal to OA square. So this length was 5 centimeter. This is 4 centimeter. So you can find OP. Now quickly tell me how much is OP. Yes, Martin, how much is OP?
3 centimeter.
Yes, it should be 3 centimeter. Right, Aisha?
Yes, ma'am.
Okay, now question number 7. Now please see in your book. I think you have book, both of you?
Yes, ma'am.
Okay.
Yeah.
Yeah, okay. I'll not be able to copy the question here. So two concentric circles are of radii 5 centimeter and 3 centimeter. Concentric means they have the same center. Okay. So one circle is like this, and then you have another circle, and they have a common center. Okay, let me call it O. Okay, of radii 5 centimeter and 3 centimeter. Find the length of the chord of the larger circle which touches the smaller circle. Okay, so if I draw, let's say this is the radius, right? And then I draw a tangent here at this point of contact. Now this blue line is a chord for the bigger circle. You know what is a chord, right? It's a line which intersect the circle at 2 points, right? So this line is the chord for the larger circle and it is a tangent for the smaller circle. Understand? Okay. Find the length of the chord. So you have to find the length of this line. If I call it AB, you have to find what is the length of AB. Yes, Subhana, can you hear me?
Yes, ma'am.
Okay, so I'm doing exercise 10.2, question number 7. So, Subhana, were you there in the first class of circles? Okay, there are two theorems. Just very quickly, just see here. Only two theorem in the chapter. The first theorem is if you have a circle, right? And this is the radius. So if you this at this point, if you draw a tangent, so this radius and tangent will be perpendicular to each other, right? Theorem number 1. Then if you have a circle and then you have any point outside the circle, now only two tangents can be drawn, okay? Like this. So these are the two tangents and this is your point A. So these two are your points of contact if you call them A and B. So according to the theorem, the length of the tangent are always equal. So PA will be equal to PB. This is theorem number 2. Is that clear?
Yes, ma'am.
So
Yeah.
these two things I'll be using. Okay. So in this question number 7, you have to find the length of this chord AB, right? Now see, if I call this P, so this OP is the radius of the smaller circle, right? Which is given in the question to be 3 centimeters. So this length is 3 centimeter. Now OA is the radius of the larger circle, which is actually 5 centimeter in the question, right? Already given 5 centimeter.
Yes, ma'am.
Okay. So how will you find AB? Okay, who will suggest me something?
I'm saying it's like it's perpendicular, right?
Hmm.
So and then we can find PB. We can
Hmm.
do the same for the other triangle. We can add that up and find the
Very good. Yes. Okay. Very good. So one by one we can take, like you name this angle number 1 and you call this angle number 2, right? So first you take the left triangle. So you write that since since AB is a tangent at P, right? So therefore OP is perpendicular on AB, okay? And therefore angle 1 is 90 degree. Is that okay? The radius is perpendicular to the tangent.
yeah, ma'am.
So now you use Pythagoras theorem in triangle OAP. Clear? Okay. So that means OA square will be equal to AP square plus OP square. Now from here, tell me how much is AP quickly. Arshia, now you will answer how much is AP.
Mm, 1 second.
Mm-hmm. It should not take this much time, right? Just
4 centimeter.
okay, Arshia. What is your answer? See, come on. OA square is AP square plus OP square, right, Arshia? Now see here. OA is 5 square is equal to AP, you have to find. And OP is 3, so 3 whole square. So 25 and this will become 9. So 25 minus 9 is equal to AP square, right? So 16 is equal to AP square. So under root 16 is equal to AP and therefore 4 is equal to AP. 4 centimeter, right? Okay, so AP is 4 centimeters. Similarly on the other triangle also. So you can just write that also by the same theorem. Now angle 2 is also 90 degree. Okay, so now you use Pythagoras theorem in triangle OBP. So this time OB square will be equal to OP square plus BP square. Now tell me how much is BP from here?
Eight centimeter.
No, it will not be 8.
It's 4 centimeter. Right? 4 centimeter.
Yes, it will be 4 centimeter again, right? So now the complete length AB will be AP plus BP. Okay. Now AP was
Oh
also
yeah.
okay. So
2
AP,
AP is 8 centimeter.
yes. So you were going on AB before telling me the length of BP, right?
Yes.
See, I mean, you people should do calculation from your hand. Okay, this will help you in exam. Otherwise, you will face problem. You'll make silly mistakes in the exam. Please don't copy calculation from anywhere or use your pen and paper. Question number 8 now. A quadrilateral ABCD is drawn. Can you see the question in your book? Right? A quadrilateral ABCD is drawn to circumscribe a circle. Okay, circumscribe means that if you have a circle, then all the sides of the quadrilateral will touch the circle. Okay, so it will be like something like this. So on every side, it is touching the circle. Is that okay? So
Yes.
the quadrilateral can be of any shape. But it will touch the circle. So if I give it name A, B, C, D. Okay, now you have some points of contact. These 4 are the point of contact where they are touching. So let me call them P, Q, R, S. Okay, so you have to prove that AB plus CD is equal to AD plus BC. Okay. Okay, so it's not tough. If you remember theorem number 2, what does it say? Now see it like this. You have the circle and then you have point A. So that means these two are tangents from an external point, isn't it? On the circle. This is your
Yeah.
P and this is your S.
Angles are equal.
Yeah, so from that theorem, your length AP will be equal to AS if you look at this part, right? So that theorem we are going to use
Yeah,
here.
ma'am.
So like once you can write the theorem that since the lengths of the tangent from an external point are equal, right? So therefore, we can say that AP is equal to AS, right? And similarly, I can say BP is equal to BQ, right? Okay, then I can say CR is equal to CQ, and then I can say that DR is equal to DS. Is that clear? I call this as equation number 1, equation number 2, equation number 3, and equation number 4. Got it?
Yes, ma'am.
Yeah,
Okay.
ma'am.
Now let us just add them, right? So adding 1, 2, 3, and 4. I'm just adding them. So it will become AP plus BP plus CR plus DR. Now equal to AS plus PQ plus CQ plus DS. Right? Okay. Now if you can see in the figure AP plus PP, if you just combine these two, what will it become? So you can just pair them, right? You make one pair and then CR plus DR is your another pair. Similarly, you can see in the figure AS plus, okay, so AS plus, then you need DS. So you can club DS here and then BQ and plus CQ. Is that clear? BQ plus CQ. Okay. So AP plus BP, that becomes your AP plus CR plus DR, that becomes CD. AS plus DS is your AD. BQ plus CQ is BC. And this is you were supposed to prove. Yes, Arshia. Okay.
Yes, ma'am.
Okay. Now please pay attention in this question. Look at this 3, right? I have written CR plus CQ. I could have also written CQ is equal to CR. The reverse way I can write. Okay. Is there any problem if
Yes,
I write
ma'am.
it like this?
No, no.
No. Similarly, this I can also write DS is equal to DR. But you have to be careful because now see, on the left hand side, you want AB and then you want CD on the left hand side. So that means the parts of the CD you have to keep on the left hand side. Getting it?
Yeah, ma'am.
So
Yeah,
therefore, I'm keeping CR on the left hand side. And similarly, I'm keeping DR on the left hand side. So that when I will add all these, so this will become AB plus CD. Is that clear?
Yes, ma'am.
So
yeah.
you have to pay attention at this part. Okay, next question number 9. Okay, so in the figure, uh, yeah, the figure is given in this question, right? XY and X dash Y are two parallel tangents. So you have a circle and then there are two parallel tangents here. This is X, Y and X dash, Y dash with center O, and another tangent AB with point of contact C. So this is O, then you have any tangent here. This is the point of contact C. This is AB intersecting XY at A. Okay. So basically this tangent intersect XY here at this point A, right? And this at this point B. Prove that angle AOB is 90 degree. So that means you have to join them. And this angle you have to show that it is 90 degree. Got it?
Yes.
So to prove that angle AOB is equal to 90 degree. Okay, so before this you write down whatever is given in this question. XY is tangent, call this point P and this point Q. So XY is tangent at P, X dash Y dash is tangent at Q. Please write complete, okay? I sometimes write very in short. Okay, it is also given that XY is parallel to X dash Y dash. And also it is given that AB is tangent at C. So these four things are given. Okay, so you have to show this angle is 90 degrees. So there's one construction, you can join OC. Hmm, 90 degree you have to show. Okay, so I'll do one thing here. I can also join this OP and OQ. This was, I think, part of question, right? OP and OQ, I think, were already joined. So I give it some name here. This is your angle number 1. I call this one 2, call this 3, and then call this 4. Okay. And also if I call these angles angle 5 and angle 6, so from the theorem I can show that angle 5 and 6 are 90 degree, right? Since AB is tangent at C. So therefore OC is perpendicular on AB. Can you see that?
Yes, ma'am.
Yes.
Okay. And therefore angle 5 is equal to angle 6 is equal to 90 degree. How? From the theorem that tangent at any point is perpendicular to the radius through the point of contact. I mean, this thing is happening at the point of contact, okay? Right. Now I'll do one thing. I take these two triangles, this triangle and this triangle, and I prove them congruent, right? So that will give me angle 1 is equal to angle 2 from CPCT. Is that okay?
Yes.
So let us prove them congruent. Now in triangle, see this is your point A. Okay? So in triangle AOP and triangle AOC. Now tell me three things quickly. Come on.
Yes, ma'am. AOP.
There are only two theorems of the circle. Okay.
Okay, the radius is equal.
Which radius? Tell me the name.
OC and OP.
Yes, very good. So OP is equal to OC. Why? Because radii of same circle, right?
Yes, of
Then,
course.
then, then,
OA and OA is common.
very good. Then one more.
Um, the triangle AOC
Hmm.
is congruent to triangle AOP. No, the
Hmm.
AOP.
Triangle or angle? See, triangle, I'm trying to prove congruent. So I need three conditions. First condition, second condition. What is the third one?
Mm, AP is equals to
Hmm.
AC.
Very good. This is again a theorem, right?
Tangent, right?
Yeah, length of the tangent from any external point are equal. Theorem number 2. Remember?
Yes, ma'am.
Very good. So I've got all the three sides equal. So this becomes SSS criteria. So triangle AOP is congruent to triangle AOC, right? And by CPCT, then I get angle 1 is equal to angle 2. So you can give this some name, result number 1. Okay. Now, by the same method, so you don't have, oh God, sorry, my cat is, no, Charlie, please go. Sorry. Okay, now similarly, see, I can show this triangle and this triangle congruent. So you don't have to do that, just write. Similarly, triangle BOC is congruent to triangle BOQ. Is that clear?
Yes.
Yes.
Okay, and that will give you, sorry, by CPCT, angle 3 is equal to angle 4. Right? Mark this result number 2. Is that clear?
Yes, ma'am.
Okay. Now, see all the angles 1, 2, 3, 4. They are falling on the line PQ. Yes, this is a line PQ and all the angles are forming on it. So if I add all the angle, it will become 180 degree,
Yes, ma'am.
isn't it? So I'm just changing the page. Have you written? Yes,
Yeah,
has every, okay.
I have three jobs.
So just one part I'm drawing, right? Not the complete figure. So you have four angles, 1, 2, 3, and 4 like this. And this is your line PQ, right? So you can say that for line PQ, so angle 1 plus angle 2 plus angle 3 plus angle 4 is 180 degree. Is that clear?
Yeah, ma'am.
Okay. And somewhere you have A, O, B like that. You can, I mean, you can see in the figure. Okay. Now, from the two results, I have got angle 1 is equal to angle 2 and angle 3 is equal to angle 4. Okay. Now, I have to show, ultimately, you have to show that angle AOB is 90 degree. That means you have to show that angle 2 plus angle 3 is 90 degree. Is that clear? If you just see in the figure.
Yeah.
Okay. Okay. So that means 2 and 3 you have to keep and 1 and 4 you have to replace. Understand? So these two you will
Yeah.
replace. Okay. So in place of angle 1, I can write angle 2 from here plus angle 3. And again, in place of angle 4, from here, I can write angle 3 again. So this is from result 1 and 2 I have used. So this becomes twice of angle 2 plus twice of angle 3 is 180 degree. So you can take 2 common. Angle 2 plus angle 3 is 180 degree. So that means angle 2 plus angle 3 is 90 degree, and 2 and 3 becomes angle AOB is 90 degree. Okay.
Yes, ma'am.
Yes, have you written, all of you?
Yes, ma'am.
Next question now. Sorry, actually I have a cat, sometimes he jump on my writing pad. So anyway, so question number 10. Prove that the angle between the two tangents drawn from an external point to a circle is supplementary. Okay, so first of all, let me draw a circle with center O, right? So prove that the angle between the two tangents drawn from an external point. So let's have an external point P and let us draw two tangents. This is your first tangent. Sorry, this is your second tangent. Okay. Let me call them A and B, the point of contact. Now read again. So prove that the angle between the two tangent, that means this angle he's talking about, okay? Drawn from an external point to a circle is supplementary to the angle subtended by the line segment joining the point of contact at the center. So you join this point of contact at the center, clear?
Yes.
Okay. Then you have to show that this angle 1 is supplementary to this angle 2. That means angle 1 plus angle 2 is 180 degree. Understood? Supplementary means sum of the angle has to be 180. Is that clear?
Yeah, ma'am.
Yeah.
Yes, ma'am.
Okay. So write down whatever is given first of all. Anyway, PA is a tangent, or you can say PA and PB are two tangents. Anyway, PA is a tangent at A, just write like that. Okay, and PB is a tangent at B. Two tangents are given, that's it. Then to prove that angle 1 and plus angle 2 is 180 degree. Supplementary you have to prove. Okay, any idea what can I do here? Okay, this is very easy. There's no problem here. Mm. From the theorem, we can show that this angle is 90 and this angle is 90.
Yeah.
If I name it 3 and 4, so you can
What's a quadrilateral?
yes. So you write that PA is a tangent at A. Okay. So therefore, OA is perpendicular on PA and therefore angle 3 is 90 degree. Please write theorem 1 here. Otherwise, you will lose marks if you will not mention the theorem. Okay. Similarly, then PB is a tangent at B, right? So therefore, OB, the radius OB will be perpendicular to the tangent. Again, mention the theorem, please. And therefore, angle 4 is also 90 degree. Is that clear?
Yes, ma'am.
Okay, now you come to the quadrilateral. So in quadrilateral, APO, AP, sorry, name properly, AOBP. we know that the sum of all the angle is 360 degree. So angle 1 plus angle 3 plus angle 2 plus angle 4 is 360 degree, right? This is called the angle sum property of quadrilateral. Okay, now you can put values. This you have already shown 90, 90. So angle 1 plus 90 degree plus angle 2 plus 90 degree is equal to 360 degree. So angle 1 plus angle 2 plus 90 plus 90 is 180 degree, right? And angle 1 plus angle 2 is, so 360 degree minus 180 degree is 180 degree. That's it. Or you can give it name. So angle 1 is actually angle APB, and plus angle 2 is angle AOB is 180 degree. So you have shown them supplementary. Yes, done.
Yes, ma'am.
No, ma'am. Good.
Okay. Next, question number 11. Prove that the parallelogram circumscribing a circle is a rhombus. So that means if you have a circle, and then if this is a parallelogram, that means it is touching the circle on all the four sides. Please draw it properly. Okay, you have to show this parallelogram is a rhombus. Give it some name A, B, C, D, and these are the point of contacts P, Q, R, S. So it is already given that A, B, C, D is a parallelogram, right? Understood? It is already given it's a parallelogram. So you don't have to prove that the opposite sides are parallel. It's already given. Is that clear? The opposite sides are equal. What is the property of a parallelogram? Just a recall. Okay, now pay attention. First of all, quadrilaterals. Quadrilaterals are basically of three types, right? Who will tell me what are the three kinds of quadrilateral?
Parallelogram,
Okay, and
trapezium,
okay,
Rhombus.
rhombus. Okay, I'm coming to it. So try to understand here. Main first thing is quadrilateral. It is basically of three types. One is trapezium, one is parallelogram, and then you have a kite. Please draw this in your copy. Okay, this is a quick recap. So you know what is a trapezium? It looks like this. So what is the two sides has to be parallel. That's it, right? And then you join them. So this figure is called a trapezium. Understand?
Yes, ma'am.
Okay. So basically in trapezium, if this is ABCD, so you should have AB parallel to CD. This is the only condition for a trapezium. Okay. Now you come to kite. In kite, it looks like this. You know how does a kite looks like, right? So basically the adjacent sides are equal. If I just call this A, B, C, D. So this side has to be equal to this side, right? So AB has to be equal to AD, and this side has to be equal to this side. So this figure is called a kite. Okay. Now parallelogram. Parallelogram means this side will be parallel to this side, right? And this side has to be parallel to this side. If also you name it A, B, C, D. So in parallelogram, what happens is AB side is parallel to CD side and AD is parallel to BC. Understand? So this property, I mean these properties can be obeyed by three kinds of figure. What are the three kinds of figures? One is called a rectangle. Then it is also obeyed in a square and it is also obeyed in a rhombus. Understood?
Yes, ma'am.
You can check yourself. If I draw a rectangle, okay, same way I am naming it A, B, C, D. So you can see here AB is parallel to CD, AD is parallel to BC, right? Similarly, if I draw a square and I name it A, B, C, D, same thing. Then you have a rhombus A, B, C, D. So all these three figures obey these conditions, right? Now, why they are different? If they obey the same condition, why they are different figures? So there are some additional things. So in rectangle, apart from this, so if you have proved this much, then it is called a parallelogram. Understand?
Yeah.
Now, if you want to prove that a parallelogram is a rectangle also, so you also have to show that AB is equal to CD and AD is equal to BC. Then it will be complete. So the first thing and the second thing you have to show. Understand? Then it's a rectangle.
Yes, ma'am.
Now, if you want to show it's a square, first thing you always have to show for all the three figures. So this will be the first thing. Now, second thing is AB is equal to BC is equal to CD is equal to AD, right? Okay.
Yeah, ma'am.
Again, if you want to show it a rhombus, so this is the first thing you will show. And the second thing you will show AB is equal to BC is equal to CD is equal to AD. Now, what is the difference between square and a rhombus? Right? The first thing is common. The second thing is also common. Then additional one more thing you have to show if it is a square. What will you show? That one of the corner angle is 90 degree. Then it will differentiate from a rhombus. Is that clear?
Yes,
Similarly, in a rectangle also you will show that angle D is 90 degree because you can have a figure like this also, right? But this is not a rectangle. Understand? This is just a parallelogram. So for it to be a rectangle, one of the angle has to be 90 degree. So I think this is a quick recap of the chapter quadrilaterals. Is that clear? Now, in this question, it is already given that it is a parallelogram. So that means condition number 1 is already given. Is that clear?
yes,
See, when the sides are parallel to each other, so this implies that the side AB is equal to CD and the side AD is equal to BC. That means this much is already given. Is that clear, Arshia?
Yes, ma'am.
Okay. Yes, Subhana, is that clear?
Yes, ma'am.
Okay, now we have to show that it is a rhombus. So that means we have to show only this thing, that all the four sides are equal. Okay, let's go to next page now. Let us draw it again. Anyway, the proper figure is there in front of you. I'm just drawing it roughly. A, B, C, D, and then you have P, Q, R, S. Sorry, my D point is just so messed up. Okay, so you write down given and to prove we have written. Now let's do the proof. So you can note a parallelogram is a rhombus with all sides equal. So we have to show we have to prove all sides equal in this question. Okay. Okay, so I start from the given condition that ABCD is a parallelogram. This is already given, right? What does it mean? It means the opposite sides are equal. AB is equal to CD and AD is equal to BC. This is a theorem that opposite sides of a parallelogram are equal. Okay. Now I again use theorem number 2 of circle that from an external point the length of the tangents are equal. Okay.
Yes, ma'am.
Okay. So since the lengths of the tangent from an external point are equal, please write properly, okay? From an external point are equal. So you have again AP is equal to AS as we have done in the previous question. Then you have BP is equal to PQ. Then CR is equal to CQ. And then DR is equal to DS, right? You can call this 2, 3. This is your result number 1. 2, 3, 4, 5. You can call it 5, 6. 2, 3, 4, 5. Now you add them again. So adding 2 plus 3 plus 4 plus 5. So if you add them, so AP plus BP plus CR plus DR will be equal to AS plus BQ plus CQ plus DS. So again, you can form pairs. So AP plus PB, as you can see, you can club together plus CR plus DR. Okay. Now AS. So you have to join DS. So AS plus DS, one pair, and then BQ plus CQ, another pair, right? So AP plus BP, that becomes your AB, sorry, plus, and CR plus DR, that becomes your CD, is equal to AS plus DS. That becomes AD plus BQ plus CQ. So that becomes your BC. Okay. Understand? See, what I'm trying to do here, now try to understand. The opposite sides, they were already equal, right? Now I'm trying to show that the adjacent sides are equal. That means AP, AB is equal to BC. This is what I'm doing here. Is that clear? Yes, no response.
Yeah, ma'am.
Okay. See, opposite were already equal. Here I'm trying to show that the adjacent are equal. So adjacent means AB and BC. So AB and BC I will keep here and the other two I will replace. Is that clear? So in place of CD from 1, what can I write? So AB plus, in place of CD I can again write AB, and in place of AD I can again write BC plus BC. Understood? Yeah. So what will I get? So I get twice of AB is equal to twice of BC, and that gives me AB is equal to BC. That's your result number 6, you can say. Is that clear?
Yes,
Subhana,
ma'am.
Subhana, is this clear?
Yes, ma'am.
Now what I will do is, now see here, I think I should use a different pen. Yeah, the opposite were equal here and adjacents are equal here. I just have to combine these two results. Understand? So from 1 and 6th. So if I combine the result 1 and 6th, how can I write it? Now see equation number 1. You have AB is equal to CD, right? Then from here, AB is equal to CD. Okay. Now see 6th. AB is what? Equal to BC. So AB is equal to BC, right? And then again you see here BC is equal to AD. So